Number 53 is again asking us to take the derivative of this implicitly defined equation. Probably shouldn't use the word function, as I often goof up and do here. And then they want us to evaluate this derivative at the ordered pair 2, 1. So let's check that, guys. We're going to get rolling right away. And the thing that I'm hoping everybody sees right here is that this original equation has a product term right there, x times y. So to come up with that derivative, we're going to need the product rule. And while we're at it, there's another one right there. So we're going to have to do the product rule twice now on the left-hand side of this equation. Since the product rule gives you a binomial each time you do it, we should end up with 4 terms on the left-hand side of our derivative. Here we go. So within the first one, guys, the first factor, x, gets multiplied by the derivative of the second term, and I'll call that dy dx, plus the second factor, which is y, multiplied by the derivative of the first factor. Well, the derivative of x with respect to x is just 1, so we're good there. There's our first derivative now. Plus, here we go, now we're going to do the product rule here. First factor, x squared, multiplied by the derivative of the second. The derivative of that y squared is going to be a 2y, and then multiplied by dy dx. Halfway home. Plus, the second factor, y squared, multiplied by the derivative of the first, which is just going to be a 2x. So there's the derivative of the second term, all of which would equal the derivative of 6, which is going to be 0. So at this point here, guys, you could continue to isolate the dy dx if you wanted, or you could put in these values right here for x and for y and see where that gets you. I think this one, because I've got the dy dx twice, I'm going to try to isolate that dy dx. So how am I going to do that? I've got 4 terms on the left and really nothing on the right with a 0. The 2 terms that don't contain a dy dx, I'm going to ship those guys over here to the right-hand side. The other ones will stay put. So that'll leave me with an x dy dx, and then a plus 2x squared y times dy dx equals, and these 2 terms move to the opposite side and they'll both become negative. Negative y minus 2xy squared. Then, I think we've been doing this long enough, guys. You're going to be okay if I do this in one step. I'm going to factor out the dy dx from these 2 terms. I'm going to bring those out in front here. Okay, and then this one too, with what's left over, I'm going to divide by that. So we're going to end up with a dy dx is equal to, this right side now becomes my numerator, negative y minus 2xy squared, and my denominator is what would be left here on the left after you pull out the dy dx's. So that would be an x plus a 2x squared y. So there's our derivative. And now, guys, they're asking me to evaluate it at the point 2, 1. So dy dx evaluated at the ordered pair 2, 1 would equal, all right, let's get to it. The opposite of y is going to be a negative 1. Ooh, and then minus 2 times an x value of 2 times 1 squared. Gotcha. And then down in the denominator, that x is a 2. Plus 2, let's see, the x again is a 2 squared times a 1. This feels like a really easy place to make multiple mistakes. So I'm going to try to go slow through all this right here. 1 squared is 1 times 2, that's going to be a 4. So this is a negative 1 minus 4. I came up with a negative 5 in the numerator there. Down on the bottom, 2 squared is 4. Times 2 is 8, times 1 is still 8. 2 plus that 8 is going to be a 10 on the bottom, and a negative 5 over 10 is going to leave us with a negative 1/2 for our numerical answer. So let me go ahead and sneak a peek at the solutions manual right here, and we came up with negative 1/2. Okay, now I just realized I didn't read my directions quite right, and I wrote it down here even too. They wanted us to find not just the value of the derivative, but the equation of the entire tangent line. So everything I've done right here was necessary and it was correct, but what we have found right here, guys, is just the slope of the tangent. When the directions are asking us for the equation of the tangent line, you need the slope of your tangent, and you also need your point of tangency. But luckily, they gave us that already. It's the ordered pair 2, 1. So Let me shrink all of this down, guys, and then zoom in a little bit differently right here. I think we're in good shape right here. So now I am going to go, as I like to do, to point-slope form. And it's going to be y minus the y-coordinate of your point of tangency, that's 1, equals the slope of your tangent, which is a negative 1/2, and then in parentheses, x minus the x-coordinate of your point of tangency, which is 2. So there's the equation of our tangent line in point-slope form. And again, I don't think they actually use the terminology. They should have. They really want it in slope-intercept. So I'm going to distribute that negative 1/2 there on the right and get a negative 1/2 x and then a plus 1. And then we'll add 1 here, and we're going to end up with, hopefully, is the right answer. Y is equal to a negative 1/2 x plus 2. And that is what we were looking for here in problem number 53. Okay? All right, so that is how we wrap that one up.